In traditional C++, the word functor is sometimes used for a callable object. But these are not the functors meant in the context of functional programming. We can think of a functor as a container holding some type and providing a way, let's call it fmap, to work on that type directly without the need to take it out. And it has to obey some laws. The first law states that mapping the identity function has the same effect as applying it directly to the container. Implementing the identity function in C++ is trivial, of course. The second law deals with function composition. It is the following. Is the maybe type we saw in the last lecture such a functor? It can hold a value of a certain type, but to make it a functor we have to define fmap for it. This function is called liftMaybe and looks as follows. It takes a function f and a maybe value and lets f operate inside that maybe. If the maybe contained a just value, the function is applied. If it is a nothing, it remains a nothing. By using it, you do not need to use unsafe getJust on your own or to take a value down from the world of maybe into the normal world, apply your function and put the value back. Instead, you lift your function up into the maybe world and you are done. Let's see it in action. But not only maybes are functors. Sequences like std_vector are too. Their templates also need one additional type to be instantiated. The fact that they hold more than one value of a type does not matter. We just have to define fmap differently. In fact, you already know fmap for sequences. You used it before and it is one of the basic building blocks of functional programming. Can you guess what it is? Remember, it has to fulfill these two laws. If you were thinking about transform, you are right. The first law again is very easy to verify. If you map every element in a sequence to itself by using the identity function, you get the same overall result as if you pushed the whole container through identity. There are a lot more possible functions. For example, one could write an fmap for dictionaries like stdmap. Oh, let's do this as an exercise. The key type stays fixed, but you allow to transform over the map values. I suggest you write liftDict as a function template on your own, so you can use it as shown.